Hey guys, sorry I can't be there today. I know you're heartbroken. I'm going to go over the notes for today, and my notes look like this instead of being printed because my printer at home has decided to just completely stop working. It's not even turning on. So I jotted down the notes and I'm going to go over this. You will be expected to watch this video and take notes. Your classwork grade for today will be showing me on Wednesday that you have taken the notes. So if you don't use your time wisely, you're going to have to do it another time, but this will be your classwork grade for today. So I'm going to take you through this. You'll be expected to complete the notes and to know this material. You have a test on Friday, but I'll be back on Wednesday and you guys can ask any questions that you have. I think it's a concept that most of you are probably already familiar with, but if you have any questions, let me know. You can send me a message through Remind or through my email address. Okay, so before we get started, I'm going to put some links to the videos or to some other videos in the description because I want you guys to watch those. So watch the first one about the density tower, I guess is what it's called. Watch that. It's only like a minute and a half, and then come back and watch the rest of this. Okay, so on that video, why do the liquids stay separated? And this would be where I would pause and wait for you guys to answer. But sorry for me pausing here. My cat was making weird noises. Why do the liquids not all mix together? It's because they have different densities. They have different sugar contents. They have the same number of water particles, but because they have a different number of particles within each of the different types of liquids, they stay separated. And the objects that are dropped within that cylinder, within those, they kind of fall to where the density level is the same. So that video is a good visual, especially since I can't be there to perform it myself, a good visual for seeing the different densities of different liquids. Okay, so a density is just a ratio comparing the mass and volume of an object. All right, and I like to call this the density triangle. If you want to find the volume of an object, the three variables that we're using here are going to be mass, density, and volume. If you want to find the volume, cover that up. What is left? Let me see if I can cover it without. All right, what's left? We have the mass over the density. So when we talk about things being a variable being over another variable, that is division. So mass divided by density. If we wanted to solve for density, for the density of an object, we'd cover that one up, and what's left? Here we have the mass is over the volume. So this one, mass over volume. All right, so when one variable is over the other, that's division. If we want to solve for mass, cover that up. Then we have density next to volume. So what operation do you think is going to be used there? It's not division. We don't have something over another. It's the inverse of that, which is multiplication. So mass is equal to density times the volume. Okay, so we have these three variables. Do you have to memorize all three formulas? Not necessarily. If you are a visual person, I am. I like this because this I can just remember the placement of the variables within the triangle. Think of the DMV if you're starting from the lower left-hand corner. But if you like formulas, if the formulas just make sense, you really only have to memorize one of them. So let's say you memorize mass times the volume. mass is density times volume. So I'm going to write over here, mass is equal to density times the volume. Well, let's say you wanted to solve for density instead of mass. If we have something being divided by, I wrote that wrong, thinking that doesn't make sense. Mass is equal to density times the volume. There we go. If we wanted to solve for just density, how could we move this other variable to the other side? Well, it's being multiplied, so we would do the inverse of that. So if we wanted to move volume, we would divide both sides by V, and here we would end up with density is equal to mass over volume. Same thing right there, density is equal to mass over volume. If we had started with this one, mass is equal to density times volume, and we wanted to solve for volume, we would divide both sides by density. That would cancel out. So the volume would be equal to mass divided by density. Same thing that we have up here. Okay, so you're just manipulating the equation, solving for whichever variable that the question's having you solve for. So the questions will give you either give you two variables, or it'll give you one variable and then it'll give you some values that you can use to find the volume, which is what we covered with the last section. You guys just took a big quiz on that. So hopefully that's familiar to you guys. All right, something else to think about with density that a really practical application is the population density. That would be the population, we're talking about the people, the number of people, sorry, the shadows are weird, the number of people within an area. So if we were talking about the population density of our classroom, what would that be? Well, I can't be there to see how many students you guys have there today, but on average, we have like maybe 25 students in class. So the population density of our room would be 25 per portable. But what if like we were comparing the population density of our class to, say, an art classroom? If we could assume they were the same size. Well, an art class is an elective, and so it's going to have more students, so it would be more dense than what our geometry class is. So the more people, or the more objects, or the more particles within a space, that is going to have a higher density. Think of an elevator. If you get into an elevator and you're the only one on the elevator, not very dense, but the more people you add to it, it's adding more mass, and so that's getting more and more dense. Okay, so let's look at a population density problem. All right, if we are comparing the population of Georgia to South Carolina, Georgia obviously has a higher population, almost twice as much, or more than twice as much. But the area is not necessarily twice as much as this one. So if we wanted to compare the population density, how many people per square mile does Georgia have, and how many people per square mile does South Carolina have? If we wanted to see which one has the larger population density, make sure that's on the screen. Okay. Sorry, there's a tripod in the way, and I'm not really sure how to do this. All right, so we are going to be looking at, we just divide, when you talk about density, population density, you're talking about people per square mile. Remember, the per word means divide. So if we're looking at 10,430,000 people per 59,425. And my writing is terrible because it's at an awkward angle. All right, so we just divide that number by that number. So 10,430 divided by 59425. And look, do you see my mistake? I forgot to add all the other zeros for the population. 10,430,000. Then divided by 59425. All right, so Georgia has approximately 170, we'll round up to 176 people per square mile. People per square mile. Okay, and then we'll use the same process for South Carolina. So South Carolina has 5,020,000 people, and the area of that is 32,020 square miles. Sorry for the background noise. My cat is driving me crazy. Allie, get out of here. Okay, so dividing that. $5,020,000 divided by 32,020. So this one is 156, round up to 157 people per square mile. All right, so if you had a question where you had to say which one has the greater population density, well, this one is larger than that one, so Georgia's population is more dense. Okay, hopefully that makes sense. All right, so now we're going to go on to the problem about the sugar. All right, we actually have two problems about the sugar. The first one is brown sugar. Okay, let me pull up my notes so I can see the wording of this one. Okay, a student measures the mass of an 8 cubic centimeter block of brown sugar to be 9.2 grams. So the 8 cubic centimeters, anytime we're talking about cubic units, that's going to be the volume. And then the mass, that is how much something weighs. And I know in science you guys learn a different definition for mass, but for what we're working with, it's basically just the weight. For our purposes, we can think of mass as weight. Try to get the lighting better. Okay, so if we were told to determine the density, remember the density is equal to the mass over the volume. So we just take the mass that they gave us, which is 9.2, and we divide it by the volume, which is 8. And the units here, it's grams per cubic centimeters. So we take 8 divided by, or excuse me, 9.2 divided by 8. And brown sugar has a density of 1.15 equals 1.15, and the units, grams per cubic centimeter. Okay, the next question, same setup, but the student measures the mass of 8 cubic centimeters of powdered sugar. So powdered sugar is that white stuff that they sprinkle on top of pancakes or French toast. It's used in making frostings. So just think about that. Do you think that is more or less dense than what brown sugar is? Just if you had to take a guess. This time the mass is smaller. It is 4.49 grams instead of the 9.2. So the density is mass over volume. So we're going to take this as the mass, 4.49 grams and divide it by the volume, which is 8, same as it was on this one, cubic centimeters, and plug that into the calculator. All right, so this one is 0.56 and some decimals. We'll just round to 0.56 grams per cubic centimeter. So the brown sugar is much more dense. It has a higher density than the powdered sugar. The only thing that was different between these, the volume was the same, the mass was different. So the one that weighed more, the one that has a higher mass or an increased mass, is going to have a higher or increased density. So increasing the mass increases the density, which makes sense because you're dividing a number here by the same volume. So if you start with a larger number, it's going to end up as a larger number. Okay? Okay, so for this next one, determine the weight of an ethyl alcohol that exactly fills a 300 milliliter container if the density of the ethyl alcohol is 0.789 grams per milliliter. So they tell us that the volume is 300 milliliters and the density is 0.789 grams per milliliter. And it says determine the weight, so that's the mass. So let's look back at the formulas. To find mass, we take the density and multiply it by the volume. So mass is equal to density times the volume. The density of this one is 0.789, and this is in grams per milliliter. And we multiply that by the volume, which is 300 milliliters. And plugging those numbers into the calculator, 0.789 times 300. So 236.7. And our final unit is in grams. Mass is measured. There are a lot of different units that they can use, but because the density is in grams per milliliter, the mass is going to be measured in grams. So you'll notice here that there's a grams per milliliter and then a milliliter. You might be familiar with the concept of canceling out units from physical science, maybe. Definitely chemistry if you've taken that. But the same way that you can cancel out numbers or variables if they're in the numerator and in the denominator, you can cancel out units. So this one was grams per milliliter, and we multiplied it by milliliters, and that milliliter was in the numerator. So if you multiplied this across, like an equals, made an equal sign, like an equation, this would be grams times milliliters over milliliters times 1, so just over milliliters. Notice there's a milliliter in the numerator and in the denominator. If that was a variable, you could just cancel that out. Well, you can cancel out the units too. So you're left with grams. So that's how we ended up with grams as our unit for the mass. Now, if you're taking the test and you give me the wrong unit, but you have the right answer, I'm not going to count it wrong. The point is for you guys to be able to do the calculations, but just an explanation of how we get to the right units. Okay, the next question. If a certain block of lead has dimensions of a 5.2 inch by 4.5 inch by 6.0 inch rectangular prism and weighs 1,587 grams, then determine the density of that block of lead. Okay, so density is equal to, look back at our formulas, mass over volume, or if you want to use the triangle, cover up density, what's left? Mass over volume. All right, so the mass is, well, it weighs 1,587 grams. And we divide it by, the volume. Well, we have to figure out the volume because they don't come out and tell us what the volume is. They tell us the dimensions of something. And this is a rectangular prism, so if we multiply 5.2 by 4.5 by 6.0, think of this as like a cube, rectangular box type of thing, like this. And it's a 5.2 by 4.5 by 6.0. I guess that one would be down here. 6.0, like that. Length times width times height. Obviously not to scale. Multiplying that in a calculator. The volume is equal to 140.4, and we have inches times inches times inches, so that's going to be cubic inches. So we divide this number by the volume that we just found. All right, so to find the density, we just take this number, divide by that one. 1587 divided by 140.4. All right, that is equal to 11.3 grams per cubic centimeter. Okay, hopefully that makes sense. Next question. Okay, this one has a lot of numbers involved with it, but I promise it's not as complicated as it seems, especially if you draw a picture of what's happening. Visuals always help me. I encourage you guys to make a chart or a graph or a visual, draw a picture. Okay, so an empty graduated cylinder has a mass of 50 grams. So I'm going to start drawing the picture. A graduated cylinder, it's just a like a measuring cup. You might have used them in science class. The cylinder has a mass of 50 grams when it's empty. And when 30 milliliters of water are poured in, Hallie, get out of here. There's my cat's butt. Don't need you up here right now. Okay. When 30 milliliters of water are poured in, right here, there's now a mass of 120 grams. Then you add a rock to it. If you guys fill up a bathtub all the way, and then you get in the tub, it's going to overflow. Your volume is adding to the volume of the water, and it's going to overflow in the tub. So the volume of the rock increases the water level, and it goes from 30 to 75. And now has a mass of 250 grams, this whole thing. All right, so what is the density of the rock? All right, to know the density, we need to know the mass of the rock and divide it by the volume of the rock. Okay, so when it's just the water, it was 120 grams. And then when we had the rock added, it jumped up to 250 grams. So the difference between that is the mass of the rock. So the mass is equal to 250 minus 120. That would be 130 grams. All right, and same concept to find the volume. It was at 30 milliliters, but then we added the rock and it increased to 75 milliliters. So the rock added 75 minus 30, 45 milliliters. So now we know the volume and we know the mass. So we can just plug it in over here. The mass is 130 grams. And the volume is 45 milliliters. All right, so now just divide that. 130 divided by 45. The density is 2.888, goes on forever. We'll round up to 2.9 grams per milliliter. Okay, all right, at this point, I want you guys to pause it and watch the video, the Indiana Jones video. I'm gonna put the link for that one in the description of the video as well. So watch that, and I think it's like 2.5 minutes, and then come back and finish this problem. Okay, so Indiana Jones, kind of an iconic scene from an iconic movie. In that, so he has this golden idol and he picks it up, and before he picks it up, he's looking at it and trying to figure out, okay, how much does this weigh? Because it's a booby trap, and he's trying to figure out the mass of that idol so that he could replace it with a bag of sand. And he's hoping that that booby trap is going to be tricked and not realize that the idol has been taken. If you watched the video, you saw that did not work. And think about how much a bag of sand weighs. A bag of sand that was about as big as he was holding, and then how much something that is solid gold would weigh. The density of gold is about 19.32 grams per cubic centimeter. That's pretty heavy. The density of sand, 2.5 grams per cubic centimeter. So the first question is, assuming the statue is solid gold, can the bag of sand and the gold statue have the same mass? That means, would they weigh the same? Because gold is significantly more dense, and because the volume of that idol and the volume of the bag of sand looked to be about the same, do you think they would have the same mass? No, it doesn't make sense. The idol would be significantly heavier. The idol would be heavier because it is significantly more dense. Okay, next one is, assuming the statue is about 1,000 cubic centimeters, what would its mass be if it were solid gold? Okay, so we know the density. To find mass, it is density times the volume. So we take this number, the density of gold, 19.32, and it's grams per cubic centimeter. And we multiply that by the volume, which they're saying, all right, assume it's 1,000 cubic centimeters. All right, so the cubic centimeters and the cubic centimeters, they're going to cancel because this one's in the numerator, this one's in the denominator. And then we're just multiplying this number times 1,000. So that's going to be we're going to add, anytime you multiply something by 1,000, you're adding 3 zeros to it because that's how many zeros, or you're moving the decimal place, the decimal point over 3 places. That's what I'm meaning to say. So it was here, we go 1, 2, 3. So 19,320 grams. All right, now that is approximately 42.5 pounds because we're not used to measuring things in grams. 42.5 pounds. Is that consistent with the way the statue was handled and tossed around in the video clip? He's grabbing it with his hand and kind of just holding it really lightly. And I mean, you know, he's a strong guy. He's Indiana Jones, but he's carrying it around like it's as much as a bag of sand is. He's tossing it around, throwing it. Even a buff person is going to have trouble throwing something that's 42 pounds. So is it consistent with the way the statue is handled and tossed around the video clip? No. They make it look like that idol weighs a lot less. So not consistent at all. All right, so I want you guys to try this one on your own. Like on the Math Nation video where they say, pause now, try this on your own, and then come back to try it. I want you guys to try this one on your own. Give it a shot, see if you can do it. All right, so while digging in the backyard, you find an old coin. If the mass is 26.7 grams and the volume is 3 centimeters, determine what the coin is made of. So if you take something to a pawn shop, they can check the density of the object to figure out if it's solid gold, because gold has a density of 19.32 cubic centimeters. If it's mixed with something else, a lighter material like copper, it might still look like it's gold, but it's not going to be as dense and it's not going to be as valuable. So places like that, they can always check. All right, so to figure out this one, if we want to figure out the density is equal to mass over volume. So we're going to take 26.7 and divide that by the volume, which is 3. And we're working with grams per cubic centimeter. All right, so we're going to take our calculator, 26.7 divide by 3. That gives us 8.9. So looking at that chart, which one of those is closer to 8.9? Well, there's only one that's really even close to that. Copper is 8.92. So why would it not be exactly 8.92? Well, maybe the scale that they used to measure only went to the 10th place. Maybe there was some estimation. They put it in to measure or check the water displacement, the same way we had the problem with the rock. And here it is. The same way they put the rock in and measured how much the water went up. If they put the old coin in and the water went up 3, maybe they were kind of estimating, all right, it's about 3. So that could be why it's 8.9 instead of 8.92. But there are no others that were on the chart that were around that. So if you were to see a question like this on your EOC, it would just make most sense that it would be copper. It's closest to that. All right, the next question. A rectangular block of material is on your dad's desk that acts as a paperweight. The measurements are 3 by 4 by 6 centimeters and has a mass of 184.32 grams. So determine what the paperweight is made out of. Again, we're going to check the density and compare that to the chart in your notes. Density is equal to mass over volume. So the mass is 184.32, and that was grams. All right, and we need to divide it by the volume, but we have to figure out what the volume is first. So how do we figure that out? Well, they tell us it's a a prism, right? Yeah, a rectangular block of material. So we're just multiplying these numbers across, right? So 3 times 4 is 12, and then 12 times 6 is 72. So that's going to be 72 cubic centimeters. So we're going to take 184.32 and divide it by 72. And that is 2.56 grams per cubic centimeter. And then looking at the chart, which one of those would make sense? There's a 2.64 that's quartz, but there's one that's exactly 2.56, and that is marble. So in case you could not tell by looking at your dad's paperweight, comparing it to, like, I don't know, maybe diamond that has 3.52. No, we checked the density, so we know it's not diamond. It's, in fact, marble. Okay, so that's the end of the notes. For your homework tonight, if you did both of the topics from last time, you are actually already done, because last time I told you guys to do section 14, topic 8 and 10. Well, this that we just did is topic 10. So topic 10 is your homework for tonight. If you've already done it, congratulations. You don't have any homework tonight. But if you have not done that yet, then you are lucky. You have an extra day, I guess extra 2 days to get it done. Okay, so right now, I want you guys to go ahead and get started on your homework. If you have any questions, email me or send me a message through Remind, okay? You will be responsible for knowing this. Your homework is this. Your classwork for today is, I want to see your notes. You keep them, don't turn them into the sub, but I will check them when I get back. Checked on Wednesday. Okay? I guess that's going to be the 27th. March 27th. All right? Have a great day, guys. I'll see you on Wednesday.